Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Okey, kita akan mulakan dengan subtopic 1.1 iaitu Dimension of Physical Quantities. Ada dua ya, kena ingat, base quantities dan juga derived quantities. Base quantities seperti length and the dimension is capital L. And then kita ada mass and the dimension is capital M. We have time and the dimension is capital T. Dan kita ada current di mana dimension dia adalah capital I. The temperature where the dimension is theta. And the last one is the amount of substance and the dimension is capital N. Untuk derived quantities, contohnya seperti velocity and the dimension for velocity is LT -1. Untuk yang kedua, kita ada acceleration and the dimension is LT -2. Dan yang ketiga, kita recall balik force. Kita ada dimension force adalah MLT -2, kita ada area which is L kuasa 2. Dan yang seterusnya kita ada volume di mana dimensionnya adalah L power of 3. Jadi bila kita tengok pada power of -2 and power of 3 untuk derived quantities mesti ada power of -1, power of -2 ataupun combination of dimension for base quantities seperti L, T dan M. Okey, jadi apa kita boleh simpulkan di sini? Di mana the dimensions of derived quantities may include few or all dimensions in individual basic quantities. Okey? Alright, good. Okey, di bahagian ini ada 3 perkara yang anda perlu ingat. Di bawah tajuk, the uses of dimensional analysis. What is the first use of dimensional analysis? Is to determine the unit of the physical quantity. Second is to determine whether a physical equation is dimensionally correct or not. Okay, kena make sure dimension of the left hand side is equal dimension on the right hand side so that the physical equation is dimensionally correct. Dan yang ketiga pula adalah to derive or construct a physical equations. Jadi ada 3 kegunaan dimensional analysis. Jom kita tengok contoh. Okey, sekarang kita akan tengok kegunaan pertama dimensional analysis is to determine the unit of the physical quantity. Alright, so let's determine a dimension and the SI unit for density. Okay, so as we know that the equation for the density, okay, so equation of density is equal to rho equal to mass over volume. So this is the equation of the density. Now we want to determine the dimension for the density and also the SI unit for the density. Okay, so the first compulsory step that you must take is you need to write the bracket, okay, in order to change the dimension of the density. Jangan lupa tulis bracket ini untuk rho and it's equal to, okay, change the dimension of mass over volume. Okay, so this is very important, this one. Okay, saya highlightkan dekat sini. Okay, and then look at here. As we know that volume, in order to calculate volume, where volume is equal to length times width times height. Okay, and we can write here that dimension of density is equal to, okay, bracket M over L, okay, don't forget the bracket, times the width times the height. Okay, and alright. So from here, you must know that the dimension of mass is capital M and dimension of length is capital L, dimension of width is capital L, and also the dimension of height is capital L. Okay, so we can write that the dimension of density, don't forget the bracket, okay, means that the dimension of the density is equal to M, capital M, okay, its dimension for mass over L times L times L. Okay, therefore the dimension of the density is equal to ML negative 3. So this is the answer for the dimension of the density. Okay, but the SI unit of density, so SI unit of density is equal to M is mass, so the unit for mass is kg, and L is the length, and the unit of length is meter. So that akan jadi M negative 3. Okay, so this is the answer. Okay, alright, so finish example number 1. Okay, now let's try second example. We consider the quantity g is equal to u squared over qh, where u is velocity, g is gravitational acceleration, and h is height. Find dimension for q and its SI unit. So here we want to find dimension for q. So we need to rearrange first this equation. Alright, so let's write the equation q should equal to u squared over gh. Okay, so the questions give us that u is the velocity, g is the gravitational acceleration, and h is the height. So remember, the dimension for velocity is lt negative 1, where gravitational acceleration is lt negative 2, and the dimension for height, since height is a length, so the dimension is L. Okay, so please remember all the basic dimension for derived quantities. Okay, so now let's continue. We want to find dimension for Q. So remember, we need to put the bracket. Letak bracket ini. Okay, and it's equal to, okay, we want to find the dimension for U. So put the bracket and square. Okay, over G, okay, what is dimension for G, and also H. Alright, so let's highlight. This is very important, remember. Okay, so now since U is the velocity and we know that the dimension for velocity is LT negative 1, so let's write Q, dimension for Q should equal to LT negative 1, but we have squared, don't forget the square of U, over G, where the dimension is LT negative 2 and H is L. Okay, now we can try to simplify, where L squared T negative 2 over, so this one L times L, and it's equal to L squared, so L squared T negative 2. So now look at here, we can cancel the upper fraction and the bottom fraction. So when we cancel, we can see that the dimension of Q, okay, so the dimension of Q is equal to 1. So when any dimension is equal to 1, means that, okay, Q is dimensionless. Q is dimensionless. Okay, so when the dimension is equal to 1, means that the dimension of Q is dimensionless and has no units. Okay, and has no units. Okay, so this is the answer. So finish example number 2. Okay, the second uses of dimensional analysis is to determine whether a physical equation is dimensionally correct or not. Ataupun kita consider equation yang dimensionally correct, kita panggil dia sebagai homogeneous, and not dimensionally correct is not homogeneous. Okay, so rule-nya untuk equation itu dimensionally correct, dimension on the left hand side should be equal to the dimension on the right hand side. Okay, look at the first equation. So we have V is equal to U plus AT. So now we want to determine whether the following expressions are dimensionally correct or not. Okay, so let's start with A, where V is equal to U plus AT, and we want to consider this as left hand side and this as right hand side, and this is also right hand side. Okay, so look at here. So we can write that the dimension, let's start with the left hand side first. The dimension of the left hand side, okay, is equal to, okay, find the dimension of V. Alright, so don't forget the bracket. So we want to find what is the dimension of V, and it's equal to dimension of velocity is LT negative 1. So we finished the first part. So let's continue for the second part is, okay, dimension for the right hand side. Okay, so look at here, for dimension of the right hand side, we have two parts. So we need to finish this one first and then find the dimension of AT. Okay, so let's write the dimension of U. Okay, where the dimension of U is its velocity and the dimension is LT negative 1. Okay, and for the second part of the right hand side, so let's write the dimension of the right hand side is equal to, okay, we want to find what is the dimension of A and what is dimension of T. Okay, so A is the acceleration, and the dimension of acceleration is LT negative 2, and for time the dimension is T. Okay, so look at here, we have LT, so you can rearrange the equation. So we have LT over T squared. So this one you can cancel, and it's equal to, okay, LT negative 1. Okay, so you can see here that all the dimension for left hand side and right hand side is equal. Okay, LT negative 1, LT negative 1, and LT negative 1. So what we can write here, we can write as, therefore, since the left hand side is equal to the right hand side, okay, means that this equation, okay, is dimensionally correct. Okay, or we can write as homogeneous. And I want to remind you that when you write left hand side, dimension of left hand side just now, we find LT negative 1, right? And for the right hand side, tengok sini, okay, disebabkan dia adalah tambah, kan, U plus AT, U plus AT. Okay, kamu tak boleh tulis that the dimension of U yang kita cari just now is LT negative 1 plus, okay, dimension of AT, kita dah cari, dia juga adalah LT negative 1. And then you write the dimension of the right hand side is equal to 2LT negative 1. Salah. Okay, look at here. So since this is the plus symbol, tak boleh pun tambah dimension of U tambah dengan dimension of AT. Tak boleh. Okay, tapi sekiranya you dapat soalan, okay, let's say lah on the right hand side, dimension on the right hand side, ini sebagai contoh, let's say you buat, you ada LT negative 1 darab times, okay, another dimension LT negative 1. Okay, so if this is the multiply symbol, then you can simplify the dimension on the right hand side tadi. Okay, so dia akan jadi L squared T negative 1 times T negative 1, so it's equal to T negative 2. Ini boleh. Kalau operasi tambah, you jangan pandai-pandai tambahkan and then it's equal to, you kata right hand side is 2 kali LT negative 1. No, tidak boleh. Okay, so for the question B, we want to determine whether this equation is dimensionally correct ataupun kita kata homogeneous ataupun tak. Okay, kita tulis balik. Oops, sorry. Okay, kita tulis balik B. The equation is V squared is equal to U squared minus 2GT. Okay, so as we know that this is the left hand side and this is right hand side and this is also right hand side. Maknanya, okay, dimension untuk left hand side ni mesti sama dengan ini, mesti sama dengan ini. Baru kita panggil equation itu dimensionally correct. Kalau left hand side sama dengan right hand side ini, tapi tidak sama dengan right hand side yang ini, equation itu not dimensionally correct. So, kita kena check satu-satu. Alright, so let's start. Okay, so let's write the dimension of the left hand side is equal to, kita ada V. Okay, dimension of velocity squared. And then, so the dimension is, velocity is LT negative 1 and squared. Therefore, the dimension for the left hand side is L squared. Jangan lupa ya, squaredkan L ni, T negative 2. This is for left hand side. How about right hand side? So look at here, the first right hand side, dimension of right hand side yang pertama, which is U. Okay, squared. Okay, tukarkan dimension U, kita tahu dia adalah velocity and it's LT negative 1. Squared jangan tinggal. Okay, so L squared T negative 2. So, kita dah selesai right hand side yang pertama. Okay, and how about the second dimension of the right hand side tadi? Kita ada satu lagi, iaitu 2GT. So, bila kita nak cari dimension, okay, any constant tak perlu pun you masukkan lah dalam dimension. Jadi, saya hanya letak dimension of G times dimension of T. Okay, so G is the gravitational acceleration. Okay, acceleration lah. And the dimension is LT negative 2. Alright, and this is time and the dimension is T. Okay, ini operasi darab kan, bukan tambah. So, kita boleh selesaikan. So, it's equal to, okay, LT over T squared. So, ini you boleh cancel. Okay, so you akan dapat the dimension is LT negative 1. Okay, so now look at here. Okay, so this is the dimension of the left hand side and this is for the right hand side. Yang pertama ini sama. Okay, but for the second right hand side ni tidak sama. Okay, jangan tambahkan ataupun tolakkan. Tengok ini simbol tolak. Okay, so kita hanya perlu tulis, okay, dimension of the left hand side is not equal to the dimension of the right hand side. Okay, therefore, okay, this equation is not, okay, is not dimensionally correct. Boleh. Ataupun kita sebut equation ni not homogeneous. Okay, remember yang U squared, okay, jangan tulis, okay, ini remember, okay, jangan tulis dimension of the right hand side is equal to dimension of U squared minus dimension GT. Lepas tu awak pergi selesaikan, awak dapat dimension of U squared L squared T negative 2 minus LT negative 1. Okay, jangan buat macam inilah. And then you pandai-pandai selesaikan, tidak boleh. So kalau dia tambah, jangan tambahkanlah macam contoh tadi. Okay, jangan jadikan 2 LT negative 1. Okay, so we finish example number 3. Okay, so this time example number 4, this is related to the uses of the dimensional analysis. Kegunaan yang ketiga, dimensional analysis adalah untuk derive and construct a physical equation. Okay, so let's read the question. We have the wavelength lambda of matter wave may depend upon Planck's constant h and mass m and velocity v of the particle. Okay, so we need to use the method of the dimensions to find the formula. Okay, so we need to find what is the formula. Lambda equal to apa? So this time we do not know what is the relationship between lambda and the Planck constant. Either they are directly proportional or inversely proportional. Okay, and what is the relationship between wavelength and the mass, and what is the relationship between wavelength and the velocity. Okay, so generally we will write as lambda is directly proportional with the Planck constant, m is the mass, and v is the velocity of the particle. Alright, so now we can write lambda is equal to, we need to put constant k and h, we write the index as x, m as y, and v as z. Alright, we don't know what is the number of the index for h, m, and v, so we need to find what is the value of x, what is the value of y, and also z. Okay, so let's find the dimension for wavelength. So we will put the bracket, so we want to change lambda, and we need to write the dimension of wavelength. So it's equal to bracket lambda, don't forget the bracket. So k is the constant, and for your information, the dimension for constant is equal to 1. So we need to write the dimension of k nanti is equal to 1. Okay, and then we will write the dimension of h. So based on the question, it's given that the dimension of h ml squared t negative 1. Alright, so kita jangan tukar dulu dimension, tulis dulu macam ini, bracketkan dulu x, okay, and dimension m, kita nak tulis dimension m nanti berapa, and also v. Okay, so now wavelength, the dimension of wavelength is L, kan? Length, kan? So capital L, and dimension of constant k is equal to 1, and this is the Planck constant where the dimension given is ml squared t negative 1 x. Okay, and mass, the dimension is capital M y, and the last one is the velocity where the dimension is lt negative 1 z. Okay, so until this part, we need to expand the index number for m, l, t, and then we need to combine the index number. Okay, so this is the mathematical part. So let's write L is equal to, let's expand the index number for m. So it's equal to mx, L2x, t negative x. Alright, so we finish this part, and my, okay, and this one is lz, t negative z. Okay, so now let's combine the index number for m, l, and t. So we write as L is equal to m, remember, mx and my, so the index number should be x plus y. Ini matematik tambahan yang you belajar masa tingkatan 5. Okay, m, so dia akan jadi apa? X plus y. Okay, so L ada apa pula? 2x and z, so it's equal to 2x plus z, and the last one is t negative x plus negative z, so dia akan jadi t negative x negative z. Okay, so kita dah sampai dekat sini. So sekarang kita nak buat apa? Tengok kepada left hand side kita, kita ada L sahaja, so we don't have m and t. So remember, okay, the power of L is L power of 1. Okay, tapi sebab di sebelah kiri kita ini, on the left hand side kita tak ada m dan t, so we can straightly put that the index number or the power of m is equal to 0 and t is equal to 0. Kita wujudkan dia dekat situ, and this one is 1, kan, L power of 1. Okay, kenapa kita nak wujudkan m power of 0 and t power of 0? Kan, mathematically kita tahu apa-apa nombor yang power of 0 it's equal to 1. Maknanya ini adalah dia macam constant 1 sahaja. Okay, so maknanya ini adalah dia sebagai constant 1. Okay, m power of 0 1, t power of 0 pun akan jadi 1. Okay, sampai di bahagian ini kita nak compare. So saya akan tulis let's compare. Compare apa? Okay, so kita nak compare di index number. Ada 3, M, T and L. Kita boleh buat satu-satu. Let's say saya mulakan dengan L dulu. Okay, saya highlight dulu. Okay, so let's compare the index number for L. Alright, so L here we have L1 and the right hand side we have 2x plus z. Alright, so tengok dekat sini. Ini yang kita nak comparekan. Okay, jadi saya akan tulis 1 is equal to 2x plus z. Alright, so 1 equal to 2x plus z. So we can rearrange this equation. Contoh kita nak rearrange, kita nak jadikan dia z is equal to 1 minus 2x. Okay, so finish the first part, and then let's look at m. So m here. Alright, so let's highlight. This is for m. So look at the index number. Okay, the power of m is 0 on the left hand side. On the right hand side, it's equal to x plus y. Okay, so let's write 0 is equal to x plus y. So we can write as y is equal to negative x. Okay, so let's say this is equation number 1 and this is second equation. Okay, so let's continue on this side. Okay, alright, so for t, okay, let's look at the index number for t. Okay, so here we have 0. Okay, and on the right hand side is negative x minus z. Okay, so kita tulislah 0 is equal to negative x minus z. Okay, so we can rearrange this equation. Kita boleh dapatkan apa? X is equal to negative z. So this is equation number 3. Okay, so sekarang ada 3 equation ni, kita boleh selesaikan untuk cari x, y and z. Macam mana kita nak selesaikan? Itu matematik lah. Okay, kalau nak saya tunjuk juga lah kat sini. Okay, kita tengok so z, kita mula dengan z is equal to 1 minus 2x daripada sini kan. Okay, z is equal to 1 minus 2x, tapi saya nak gantikan x saya ini, negative z. Okay, sebab saya nak cari nilai z. So, saya selesaikan. Okay, and finally, I will have the value of z, where z is equal to negative 1. Okay, so saya dah dapat nilai z. And then, for y, or for x, okay, so from third equation, x equal to negative z. So, kita boleh masukkan negative. Negative z sini kan. So, nilai z dah dapat tadi. Kita gantikanlah. So, x is equal to negative 1. Where x is equal to 1. Okay. So, bila dah dapat nilai x, finally, kita boleh cari nilai y. Therefore, y is equal to negative x from the second equation here. So, y is equal to negative 1. Okay, so sekarang kita dah selesai cari nilai ini. Kita ada z, kita ada x, and kita ada y. Okay, so jom kita tulis relationship. Saya dah tak muat dah nak tulis ni. Okay, tak apa, saya tulis kat sini, kecil je. Okay, saya buat line dekat sini. Okay, so now, as we know that lambda is equal to k, hx, my, vz. So, let's substitute the value. Where k is the constant, h, x tadi kita dapat apa? 1. M, kita dapat apa? Y tadi kita dapat negative 1. And v, power of z, where z is negative 1. So, kita tahu bila m negative 1, maknanya dia duduk di bawah. V-1 dia duduk di bawah equation. Apa maksud di bawah equation tu? Dia adalah lambda is equal to KH over. Kan, sebab M power of -1 dia akan duduk dekat bawah fraction, V power of -1 dia akan duduk dekat bawah fraction. Jadi sekarang kita dah dapat dah formula untuk wavelength. Kan, dia kata tadi, soalan kata use the method of dimensions to find the formula. And then finally we have find the formula of lambda is equal to KH over MV. Okay, finish example number 4. Semoga video ini boleh membantu anda belajar sambil berehat. Jumpa lagi. Assalamualaikum dan selamat sejahtera.